A graph usually looks like the image below and made up of vertices and edges. This is an example of graph having a set of vertices and the set of edges. Some of the practical scenarios where we can use the graph to represent data are social media connections like Facebook. Every user can be represented as a node or vertices, and the nodes can be connected with each other with the help of some edge. Breadth first search is a graph traversal algorithm that starts traversing the graph from root node and explores all the neighboring nodes. Then it selects the nearest node and explores all the unexplored nodes. The algorithm follows the same process for each of the nearest node until it finds the goal. The algorithm starts with examining the node A and all of its neighbors. In the next step, the neighbors of the nearest node of A are explored, and process continues in the further steps. The algorithm explores all neighbors of all the nodes and ensures that each node is visited exactly once and no node is visited twice. At first, we should know these two words' meaning. Visiting a node. Visiting a node means to visit or select a node. Exploring a node. Exploring the adjacent nodes of a selected node. In this example, we want to find minimum path from point A to point E using breadth first search algorithm. At first, we visit node A neighbors. They are B and D, so mark A as visited. In the table write A in from column in front of B and C. It means moving from A to B and from A to D is possible. In the cost column, write the weight of connection between starting point and B and D. Second, visit all neighboring nodes of B, node C, and node F and mark B as visited. Apparently, moving from B to E is not possible. In the table write B in from column in front of C and F. It means moving from B to C and from B to F is possible. In the cost column, write the weight of connection between starting point and C and F. Third, visit neighboring nodes of D since F is already visited by B. So mark D as visited. Fourth, moving from F to other nodes is not possible, so mark F as visited. Repeat the steps for all nodes until each of them has been visited at least once. Mark nodes you considered visited. Now, in the table, backtrack from point E to point A. So the minimum path would be A to B, B to C and C to E.